2.1 Set Concepts. Set. So a set is a collection of objects which are called elements or members of the set. There's three ways or three methods we can use to indicate a set. We can use description, which is like using words. We can use roster form, which you've seen before, and set builder notation, which some of us might be super common with but didn't know that that was the name, set builder notation. So a well-defined set. A set is well defined if its contents can be clearly determined, not biased. So an example, the set of US presidents is a well-defined set because its contents, the presidents, can be named. We know all the presidents we've ever had since the beginning of this country, so that's a well-defined set. So an example of a not well-defined set, the funniest person in your class. That's very subjective because what's funny to me might not be funny to you. So anything that's not biased or subjective, that's a well-defined set. So if I said the set of best luggage, that's not well defined because who knows what's best? Maybe you want a hard case, maybe I want a soft case, right? We don't know what's best. So as long as it's not biased, it's a well defined set. Description of sets. So we're going to write a description of the set containing the elements January, February, March, April, May, June, July, August, September, October, November, December. So if we think about what are those? Those are months of the year. So that is actually the answer. So if we want to use description, meaning using words to describe what's happening here, January, February, and so on, those are months of the year. So this is the set is months of the year. Roster form, listing the elements of a set inside a pair of braces. Those little squigglies, those are called braces, is called roster form. So the example, if you have braces 1, 2, 3, that's saying it's in roster form and the elements are 1, 2, 3. If you have parentheses or brackets 1, 2, 3, those aren't braces, so they're not a set. It doesn't represent a set. So to represent a set, it needs to have the little squigglies, which are called braces. If you have a hard time drawing the little squigglies, like I do, they're not very well, so these are the little squigglies I'm talking about. If you have a hard time drawing them, you can do like little threes. That looks very similar. I don't draw them very well, so it's okay if you don't. As long as I know it's a squiggly, just make it squiggle for me, and I'll know what you're talking about. It's a brace. So naming of sets. Sets are generally named with capital letters. So generally speaking, meaning most of the time we say capital letters. So definition, natural numbers. Natural numbers are also called counting numbers, and we would say n equals 1, 2, 3, 4, 5, 6, 7, 8 for forever, right? Because natural numbers, we can keep counting until we die. Natural numbers are called counting numbers because when we count things, we don't go -1, 0, 1, 2. We don't do that. We count things as one thing, two things. We don't say we have 0 apples, right? We say we have 1, 5 apples, right? We say we have some type of apples. Also, counting numbers, we don't count like 1.1, 1.12, 1.13. We don't count like that. We count 1, 2, 3, 4, 5. We count whole numbers. Roster form of sets. So we're going to express the following in roster form. Set A is the set of natural numbers less than 6. Set B is the set of natural numbers less than 6 or equal to 45. And set P is the set of planets in Earth's solar system. So set A is the set of natural numbers less than 6. So all the natural numbers less than 6. So we're saying A, it's all the natural numbers less than 6. So 1, 2, 3, 4, 5. So those are all the natural numbers less than 6. And remember, they're natural numbers because they're called counting numbers, and we don't count -1, 0. We don't start that way. We start at 1. Alright, so set B is the set of natural numbers less than or equal to 45. So we're saying B is the set of all the natural numbers less than or equal to 45. That means every counting number from 1 all the way to 45. The A, that's less than 6, that's why we don't include 6. But for B, it says less than or equal to. That means we include 45. Now, I don't know about you, but I'm not going to write 45 numbers. I'm not going to go 1, 2, 3, 4, 5, 6, 7, 8, all the way to 45. So what we do is we go 1, 2, 3, dot, 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 45. Because what that is telling the reader is that it's still all the counting numbers, just all the way to 45. If you want to, you can write all of them. You can write 1, 2, 3, 4, 5, 6, and so on. But if you're talking about a large set of counting numbers, you can put dot, dot, dot. Alright, set P is the set of planets in the Earth's solar system. So we're saying P is the set of all the planets in our system. So it starts with Mercury, then it goes to Venus, Earth, we're next, Mars, Jupiter, Saturn, Uranus, and Neptune. Alright, set symbols. The symbol, it looks like an E. That's red is an element of. So E, element, it makes sense. Math makes sense sometimes. And it's used to indicate membership in a set. The symbol with a line through the E means is not an element of. Anytime you want to say is not, it's usually a line. And you're going to see that through Chapter 2 and Chapter 3, how we say not in something. Set builder notation, it's also called set generator notation. This is the one that you're probably familiar with but never knew what it was called. So it's a formal statement that describes the member of a set and it's written between braces. A variable may represent any one of the members of the set. So we're going to use set builder notation. We're going to write set B 1, 2, 3, 4, 5 in set builder notation. So we're going to go from roster form to set builder notation. So anytime we do set builder notation, we start off with what set are we talking about? Well, we're talking about set B. We're going to put our little squigglies, also known as our braces. And this is how we're going to start it off. We're going to pick a variable. 99% of the time in math, if there's no specific variable to pick, we pick x. So we say x such that. It's actually that little thing, that little line means such that. So we have x such that. Now, 1, 2, 3, 4, 5, those are counting numbers. If I said 1, 2, 3, 4, 5 to a kid, they'd be like, oh, you're counting. Or if I said count to a little kid, they're going to go 1, 2, 3, 4, 5. So counting numbers are also called natural numbers. So we're saying all of these elements in the set are natural numbers. And all those numbers are less than 6, because 1, 2, 3, 4, 5, those are less than 6. You could also say B x such that x is an element of all the natural numbers, and x is less than or equal to 5. Those mean the same thing. Because if you're saying less than 6, that's 1, 2, 3, 4, 5. If you're saying x is less than or equal to 5, that's still 1, 2, 3, 4, 5. So now we want to write in words what we just wrote. It's going to help break it down a little bit. I'm going to rewrite the top one. Alright, so how we rewrite this, I'm going to break it down piece by piece. So we're saying set B equals always means is. So now we have the set of x. So we're saying braces, which means the set of. So we have the set of, and now we have x. So all of our x's this little bar means such that. Then we have x is an element of all the natural numbers. So we're saying x is a natural number. And then we have our word and. Then we say x is less than 6. So using words, read along as we go through the set builder notation. So we have set B is the set of all x such that x is an element, or sorry, x is a natural number. That's a way to say x is an element of natural numbers. And x is less than 6. If you wanted to write the bottom one, everything would be the same except the purple. We would just say x is less than or equal to 5. Example 4. Set builder notation to roster form. So we're going to work backwards now. So we have set builder notation. Now we want to list those numbers in roster form. So we're saying set A is a set. See how it looks very similar? Is the set of all x. X is a natural number, and the numbers are 2 is less than or equal to x, and x is less than 8. So we know this means right here we're working with counting numbers. Counting numbers are 1, 2, 3, 4, 5, 6, 7, so on. So we're going to use those natural numbers and count from 2, including 2, to 8. Now we include 2 because of the line underneath. That line underneath tells us we include 2. So we're saying set A equals the set. We're going to start at 2. Then all the numbers from 2 to 8. So 2, 3, 4, 5, 6, 7. Now we stop there. The reason why we stop there, because next to 8, there is no line underneath. Since there's no line underneath, we do not include the 8, we stop at 7. Alright, I want you to pause this video, and now this is going to be a theme through the whole semester, where if you're watching a lecture video, I'm going to ask you to pause it and actually try something, like Dora the Explorer. Like, literally think of when you're watching kid shows like Mickey Mouse Clubhouse or Dora the Explorer or Bob the Builder or Blue's Clues, where if I tell you to do something, do it, because that's how you're going to learn. That's why they do it with kids, because they learn, and it's actually really fun. I know, like, you're not cooler than this. It's going to be really fun. So what I want you to do is pause the video and actually try example 5 on your own. So pause it. Okay, I hope you paused it. I hope you did. If not, I mean, you're gonna do what you're gonna do to feel comfortable, but I hope you did pause it, and let's do it together. If you had to look up all the continents, that's okay, you know. This is the math class, not geography, so it's all good. So let's write set C equals x such that x is a continent, and then we're gonna write in words how you would describe C in set builder notation. Alright, so let's write C in set builder notation. So set C equals all of the, in roster form. We're going to write it in roster form. So we're going to write all the continents. So we have North America. We have South America. We have Europe. We have Asia, Australia, Africa, and the last one, Antarctica. So now we want to write part A, x is such that x is a continent. We want to write that set builder notation in words. So in words, we would say X, so set C is a set of X such that X is a continent. So set C is a set of all elements of X such that X is a continent. You're probably picking up already of where you just write what's in the set. You just have to write the fancy part. Set C is a set of all elements of X such that. You're usually going to write that all the time, and if you look at example 3, we wrote very similar things. And then we wrote whatever's in those braces. Alright, example 6. Elements of a set. So determine whether each set is true or false. If false, we're going to state why. So let's determine if blue is an element of set orange, yellow, blue, green. So what is this asking is blue inside those braces? Yes, that's true. They are. It is. It's true because blue is an element of the set. Meaning blue is inside the set. It is. So now we want to know remember, sets are written to us using squigglies, using braces. So if you see a brace, you're talking about a set. So for B, we have set sapphire is an element of set gold, diamond, ruby, sapphire. This is false. It's false because what this means, what they gave us, set sapphire, that is literally saying that you have a set. That's saying set sapphire. Now, what we're given set gold, diamond, ruby, sapphire. Now, set sapphire is not inside set gold, diamond, ruby, sapphire. Because you're saying that the set has to be in the set. Sapphire is just an element of a set, not a set itself. Finite set. A set that contains no elements or the number of elements in the set is a natural number. So 2, 4, 6, 8, 10, that's finite because that's just 2, 4, 6, 8, 10. There's nothing more about it. It also has 5 elements. 5, that's a natural number. We can count. We have 5 things in there. We know exactly what it is. Infinite sets. A set that is not finite is to be infinite. The set of counting numbers is an example of an infinite set, and how we say infinite is ... Equal sets. Set A is equal to set B, and it's symbolized capital A equals capital B if and only if set A and B contain exactly the same elements. So 1, 2, 3, that set, it's the same thing as 3, 1, 2. Order does not matter with sets. Sets are just elements, so it doesn't matter your order. Cardinal number. The cardinal number of set A, symbolized n of A, is the number of elements in set A. So set A, 1, 2, 3. Set B, England, Brazil, Japan, meaning they have 3 elements in each set. So their cardinal number, your number of things in set A is 3. Your number of things in set B is 3. Equivalent sets. Set A is equivalent to set B if and only if you have the same cardinal number. So set D, ABC, set E, apple, orange, pear, they have the same amount of elements, so they are equivalent. Remember, equivalent is it looks the same. It's not the same, but it looks the same. Equal is the same. So looking the same, meaning they have the same number of elements. They have the same cardinal number. They have the same cardinality. One-to-one correspondence. Set A and set B can be placed in one-to-one correspondence, and every element of set A can be matched with exactly one element of set B, and every element of set A or B can be matched with exactly one element of set A, literally meaning 1 to 1. One thing goes to one thing. So a great example of that are states and capitals. So S, that represents your states, set C represents your capitals, because a state can't have more than two capitals, and no state shares a capital, right? Each capital is its own. So North Carolina, that's Raleigh. Georgia, that's Atlanta. South Carolina is Columbia, and Florida is Tallahassee. They don't share anything, so it's one to one state to one capital to one state. Of course, you can mix this up however you want, but we're being literal here, meaning one state to one capital. Null or empty sets. So the set that contains no elements is called the empty set or null set, and it's symbolized by open braces or a circle with a line through it. So note that a brace with a circle with a line through it, that's not empty because it has something in there now. It has an element. It's an empty element, but it still has something in there. It has a cardinality of 1. Also, if you have a set of 0, that's not an empty set. That means your element is 0, and it still has a cardinality of 1. Universal set, we're going to talk about that for like 2.3 on. So universal set is symbolized by a capital U. It contains all the elements for any specific discussion. So if we ask the class, what's your favorite color? All of your answers, that's the universal set. Then we could break it down into this many people like blue, this many people like yellow, this many people like orange. And those are your sets A, B, C, and so on. When the universal set is given, only the elements in the universal set may be considered when working with the problem. So if I ask the class what's your favorite color, I can only go off of your answers because that's the universal set. If the universal set is defined as 1, 2, 3, 4, 10, that means you can only work with natural numbers 1 through 10. So if this was the universal set, I can only work with all of those natural numbers 1 through 10 in the question that it's asking me.